Good morning, good afternoon, and good evening, wherever you are. Thank you for joining. At CIQ, we're focused on powering the next generation of software infrastructure, leveraging the capabilities of cloud, hyperscale, and HPC. From research to the enterprise, our customers rely on us for the ultimate Rocky Linux, Werewolf, and Apptainer support escalation. We provide deep development capabilities and solutions, all delivered in the collaborative spirit of open source.
Okay, hello and welcome. Oh my goodness, look at this team. This is very exciting. Hello, everybody. Thank you so much for being here. I'm really excited to talk about RLC-AI, optimizing Linux for AI and ML workloads. But first, let's say hello to everybody. So you guys probably know me, Rose Stein here, working at CIQ in the sales department. Very glad to be here with Brian Dawson. Unmute and introduce yourself. Unmute. Yep, you got to unmute. Mute. Okay, maybe we'll come back to Brian. Brady, you're up.
Hi there, Brady Dibble, product at CIQ.
That's it.
And I'll come in.
Short and sweet, man. I like your style. Okay, Brian. How's it going?
I am Brian Dawson, product at CIQ, and I ran into Chrome tabitis, and I lost my StreamYard window. So I am now here. Thanks for having me, Rose.
Chrome tabitis. You heard it here first. It has been coined by Brian Dawson. That is awesome. Thank you so much. We all know exactly what it is that you're talking about. Where am I? Where's the voice coming from? What's happening? That's awesome. Well, very glad that you were here. And Rob DeFollow, how's it going, man?
Doing well, Rose. How's it been? Been a little bit.
It has been a little bit. I see you've got we've got the same letters but different colors. I'm liking
yeah.
it.
I got to get some of the new gear, I guess, but no, I think this. I got this with the last one, but yeah. So now my little title says Head of Strategic Projects. Here I am again, doing new things.
There you go. Yes, that's actually one of the fun and wonderful things of a startup is that there's movement, right? You come in, you're like, all right, this is what I'm doing. Just kidding. This is what I'm doing.
I think I've had about a half a dozen titles since I started here 3 years ago, but yeah.
Yes.
This is my favorite one yet.
Okay. Maybe we'll just kind of like settle in here a little bit. I like it. Well, glad that you were here. Thanks, Rob. And of course, Zach. So you're actually, I think, the newest addition to CIQ. So tell us about yourself.
Yeah. Hey, so I've been advising the team here on AI applications for Rocky Linux and many other projects. I am the head of AI at AI Insight Solutions, which is a consulting firm, but I've been working very closely with these guys. I'm quite excited to see what they've built.
Yeah. So this is a hot topic, you guys, because AI, like, what is AI? There's lots of feelings and emotions around AI, and then there's the technical details. So we're definitely going to dive a bit more in here. So I think who's going to do that, like just the RLC AI overview? Kind of tell us what are we talking about here?
Well, I'll start, and then I'd love for Brady to chime in. So, I think we're here because last week we announced that we are actively building Rocky Linux from CIQ for AI. And what that is, well, we realized first that I think it's 94% of AI workloads are running on Linux systems. However, a good majority of those are not at all optimized to support AI. They are general purpose Linux distributions. And in fact, many of them are not even enterprise Linux distributions with sort of the enterprise grade upstream support. We also realized that inferencing is very expensive. And those two things present an opportunity for us to build and deliver RLC-AI to help people running or delivering AI workloads at scale via production inferencing to reduce cost, optimize performance, and reduce the overhead in customizing, modifying, and deploying Linux to support those AI workloads. And Brady and team here have identified a number of features that meet that target or meet that need for those people running AI at scale.
That was a lot of words, Brady. What did he say?
So the past couple of years, AI has exploded and everybody has to have an AI project. And a lot of the focus and discussion has around AI infrastructure has been about getting from 0 to 1. CIQ works with a number of customers who they're already in production and they get it out into production. They go, wait a minute, I'm not going as fast as I want. Wait a minute, I've got all this expensive hardware. Why isn't it going as fast as it said on the brochure? My Ferrari is, stuck in first gear. Or wait a minute, I have to keep bringing down like new CUDA drivers all the time. I have to keep dealing with dependency, heck, with all of these new like drivers all the time, compatibility issues every time I update. I have to rebuild this OS constantly to keep it fine-tuned. And we found that we could actually support a lot of our customers with making that just go faster. With the RLC-AI, there was a couple, like 3-4 main areas that we're focusing on. The first was all of the nice new stuff is in the upstream kernel. So the first thing we were doing is bringing down the new kernel to say, hey, everything you want is already in that upstream kernel. We're going to make it easy to access everything as soon as it comes out. The second one is your generic kernel, the off-the-shelf kernel, that's for general purpose. So even things like changing the build flags that are used when you're building the kernel can have monumental impact on your performance at scale. And then, we start bringing in, there's out of tree drivers and there's other optimizations, there's frameworks, there's compatibility that you have to deal with. All of that goes away with RLC-AI.
Wow, that's a bold statement. All of that goes away. Zach, do you agree?
Yeah, I mean, that's the whole point of it. I mean, as a consultant, I spend a huge amount of my time dealing with dependency heck, installing drivers, just getting a fully compatible stack from your drivers to CUDA, to the CUDA toolkits like CUDA DNN, to PyTorch, to Python. Like building out all of that yourself every time is difficult enough. Keeping it up to date is just way more work than I ever want to do. I love systems where vendors such as all of you, all of us, package that up and you can just install it and run with it. It's work nobody wants to do. It's work that's great to do once and then push out to everyone.
Nobody wants to do it, huh? Is that true,
yeah,
Rob?
Yeah.
And I'd add that, and it requires a special expertise that, frankly, a lot of organizations that need to move quickly don't necessarily have. Right. Right. So I think a lot of you get a lot of people, honestly, sysadmins, Linux sysadmins that have to do this to support this core business initiative. They don't know how. So yes, I don't want to be burdened or straddled with ensuring, with owning the foundation for my company's AI workloads while I don't have that expertise. So hence CIQ hopes to empower those people.
Yeah. And there's there's a gap between, on the one hand, you've got some researchers saying, oh, I want to use flash attention to make this model faster, but the CUDA version we have doesn't support it. And then you're going out to a sysadmin and speaking a bunch of words they don't understand because they haven't heard of flash attention before. And there's this whole compatibility layer of there's some feature in the newest version of Torch you want to use, but your stack hasn't been built to support that all the way through on the hardware you're on. And so the feature you want doesn't work, but you're out here at this end, in PyTorch land, and your sysadmin's over there in hardware land. And there's a lot of steps to cross in between to get to the point where you're speaking the same language and you're on a stack that's doing what you want in user land.
User land. So, I mean, there's got to be a reason, right? There's got to be a reason that people, not a lot of vendors are doing this. What is that reason? I'm gonna pick on Rob, right? Rob,
I think this is more of a Zach one, to be honest. Because
is it? But you've been all over the place, especially inside of this company and in other companies. So I think. I don't know. Okay, you want to pass on to Zach?
No, I mean, I think that when you really look at it, from my angle. So whereas that comes down from like the top down, I come from the bottom up, right?
Exactly.
So when you look at the hardware and a lot of what's going on there, one of the biggest challenges in deploying AI right now is the hardware layer that's out there, how fast it's growing, and those challenges around it, right? So you have these big production environments where there's a lack of timely support for Linux kernels. Maybe the drivers, the MPUs, and other accelerators that are coming out are completely dependent on what's going on with NVIDIA, AMD, Google, ASIC, and all the other ASIC kind of providers, right? So you have kind of this lag behind the mainline releases that require like custom patches. So when one of these people come out with this new tool that just landed on the market, as Zach kind of talks about, you now have to figure out what that whole dependency tree looks like, all the custom patches, forcing teams to choose between different kernel stability, security, and then just the hardware enablement in general. So not all kernels are created equally, especially when it comes to like the IO performance and when the workloads are running on those. So while you might have some really great hardware out there, if the kernel isn't using that IO well, you could be looking at bottlenecks within that area. And how efficiently you can move data, right? The core of all this is data, data, data. What's that need? Memory, hardware, and the ability to push between those. So efficiently moving that data between storage and the accelerators and the drives, all that's a really big deal. So that's kind of what the core of what we've been digging into for the last 4 or 5 months here is just what that looks like and how can we better accelerate that for customers.
Yeah. And there are vendors trying to solve this problem, but a lot of it is, hey, here's a Docker container. There's not that last step down to the hardware level, down to the kernel level.
Right.
I would, Rose, just to chime in. Look, so technology adoption and penetration over the past couple of decades has continually increased from looking like this to looking like this. We have this well-funded AI race where we have multiple layers of a complex problem for companies to figure out, get deployed to scale. I remember I was watching a talk at a machine learning symposium recently, and God, it wasn't Amazon. I am losing it right now. Let's say it was Expedia. And she's telling the story of she presented research work to the company execs, fully expecting she'd say she needed 2 more years to develop this and productionize it. They told her they wanted it productionized in a month, right? They went ahead and did it. It saw success, but you have this complex stack of problems that people have to deal with. And not surprisingly, people are ignoring what's happening down where the software touches this valuable hardware, the OS layer, right? And so we're here to solve that, to call attention to that gap and help close that gap out.
That's awesome. So tell me a little bit more, like you guys have already touched on it, but I think this is a really important part of RLC-AI is what is different from like the base Rocky Linux image. Exactly.
I would love that's a Brady. That's a Brady.
Yeah, what's different? Well, when you're taking a distribution broadly, especially for enterprise, you don't necessarily know what the customer's use case is. So enterprise Linux distributions are designed to be somewhat general purpose. And then the customer is expected to add on additional optimization themselves, or they have to go through professional services to have someone else do that maintenance for them. And you create a custom one-off. CIQ's like workload specialized products, RLC-AI and the recently released RLC-H, that's doing a lot of that out of the box. So you have a gold image that already has that heavy lifting done for you and is reproducible in a way where you do not have to be the one constantly keeping up with all of these drivers, all the compatibility, the optimizations, any little challenges with build flags. So the first difference is saying we're going to take this and just make this optimized for AI use cases out of the box, these specific workloads, tuning and inference primarily, because that's where you're not going to get the most out of your OS unless you're literally building like at build time specifically for this use case. Because you're turning off a lot of things. There are trade-offs. Essentially, you're not going to use this and then go run a regular web server. This is specifically for AI use cases, and you're using it for tuning or using it for inference. And when you are, as we talked about, when you're actually productionizing your AI workload. You finally get it out. You've done all of this work. You've set up your AI infrastructure. You've got it in production. And then you look at your bill and you go, oh my goodness. As we've probably heard, every time someone pings an LLM, that's costing money. And so any improvement in performance, that's saving you money. And simultaneously, if you can improve things like latency, that's improving the customer experience. That lag between when they submit a query and when they get that response back, that's massive in the customer experience. So making those building from the beginning with the idea of this is a single purpose use case to an extent of we're maximizing your AI infrastructure for AI LLM and ML workloads. Just starting with that idea is already a major mind shift.
Mm-hmm.
Then we are working on, now when we get into the technical specifics, that's when we start talking about specific build flags, specific feature support, specific hardware support, the GPUs and all the other PUs that are being utilized, making sure that that's not just compatible, but you're getting the most bang for your buck. And performance is absolutely critical, but now you're in production. Now you've got other concerns. What happens if it breaks? How do I get support for this if I'm just pulling things from the community and doing it myself? What about security and compliance? We've seen, along with this push for performance, also now that it's in production, like I said, get it out in a month. Great, it's out in a month. Now make sure it's secure and compliant. That's a bigger deal. Encryption at runtime is, like with confidential computing, has become a hot topic this year, because especially for like multi-tenancy scenarios, if you're running in a multi-tenant environment, you need to make sure that your work can't be seen by the other tenants. So that's where things like confidential computing come in. Now you're in production. You don't want security and compliance to be an afterthought.
No.
I call out, and maybe Rob is better to talk to it, or want someone else here, but we identified that the absence of the latest upstream kernel and some of the AI focused Linux distributions out there today are really hobbling teams. So I think a key feature where we say, what is a major difference between RLC-AI, as we call it for short, and Rocky Linux? It's going to be how we handle the kernel updates and pulling the latest upstream kernel forward.
Yeah, that makes sense, Brian. And to that, like, that's some of the things we really looked at when we started digging in. Linux is just now really starting to truly like embrace a lot of what's going on with this. Like they're getting up there and they're looking at like the latest like 6.13s builds and such, start looking at like some of the ARM support we need, like ARM 9A, where you really start to see the ability to address memory much faster. And so the core things we really looked at is like, when we started digging into this, is like performance benchmarking and validation around those kernels. And then what can we do to be better about rapid adoption of new hardware as it comes out, because it's going to be very important to us. And then obviously the thing everyone's here for, ease of model deployment when using this. So those are the three core things we looked at when we really started digging into what we're going to do with this kernel and this entire product.
And it's like one of those things you said on, like memory paging speed, like that's, especially at inference time, one of the biggest factors limiting like throughput tokens per second coming out of your models is your memory bandwidth.
Yes.
Like that's where it really pays to have the whole stack optimized for, look, I have a huge amount of data in RAM and I want to be able to access all of it very, very, very quickly. And that's not a problem, that's a non-trivial problem to solve.
Definitely. And especially when we start looking at these bigger models where they start thrashing memory, the ability to page out and such much faster is going to be a big deal when you're talking about like warm versus cold startup of these models.
So one of the things that you mentioned, I think Brian is just talking about like how many people are using Linux that are running AI workloads, and it was all the vast majority. But how many people are running AI that are at all? Like almost everybody? I don't know. Is there anyone who's not?
I'm going to lead to Zach. Since my name was on the front of that, I'm going to say I don't have a specific number. I probably do. I can't recall it. But But I think we know. I will share one thing before I go to hand to you, Zach. We know venture money fuels a lot of this innovation, right? And people that aren't venture backed, we already know, the big fangs are all leaning into AI. I was reading an article yesterday that said over 50% of venture funding last year went into AI focused companies. So I will grossly say before I hand to Zach, the bigger question is who is not engaging with and running AI workloads. Right? But I'm going to go to the expert. I probably should let the expert go first.
Yeah, I mean, I don't have a statistic off the top of my head. I have anecdotes, and as we all know, the plural of anecdote is not data. But every single client I consult with is thinking. I mean, I don't think there is a company that isn't thinking about AI to some degree. Like it's going to affect the entire economy.
If my mom is running an AI app on her phone, it's literally everybody.
I went in for my annual physical yesterday, and my doctor had I asked him a question, and he's like, "Hang on a sec, let me check the research." And he's got it's actually a very cool app for searching scientific articles and summarizing them for doctors. And I mean, this guy's an internist at MGH here in Boston. I've never talked to him about AI before. I'd only talked to him about, hey, keep working out and, whatever. And it's amazing. But what I will say is you got to remember, for every person using AI, there is, a company on the back end managing all of those servers that run it. And so that's the thing to keep in mind here is it doesn't take many companies deploying AI to reach a huge number of users. Like the scale of these deployments is massive. And even if a given company isn't necessarily building and deploying their own AI systems, they're almost certainly using someone else's AI systems. I mean, it's getting baked into everything from, Google Meet's transcription features, which I really love. And there's a million products doing that, to all sorts of other things. So all of those cases, as the scale grows exponentially, the compute needs grow exponentially. And, it takes a number of years to put those new data centers out in the desert. It's a much better idea to get more out of your existing hardware.
Mm-hmm. Yeah, the thing I'd say on this, and talking with some hardware vendors that I know, they kind of say, hey, this kind of goes in 10-year bubbles, and we're kind of in the 2020 bubble right now. And right now, if your technology company isn't looking at how they can either use AI or ML style loads, they're going to be behind the eight ball with a lot of what's going on. If you have any kind of forward-looking strategy, you should always have something at least looking around in there and understanding how it can help be applied to your work or your just work.
Yeah. Well, so I mean, that makes sense with using the upstream kernel, because then you get the newest drivers and hardware and the most newest stuff because it's changing so quickly. But how upstream, right? There's lots of versions of upstream kernel. Is there a specific one that is being used? And then how long does it stay on that one? Do you have to do a whole, reboot every time? How often is it? I'm so curious about this.
Yep, we're getting, CIQ has a strong relationship with the upstream, and we are getting at bit for bit with what is kernel.org kernel. The same kernel you would take from kernel.org. That's what we're building and optimizing for, because the pace of development is so quick that the moment you start forking that upstream, you are now, to an extent, behind. The RLC-AI is starting with the 612 long-term kernel as its foundation, and we're also even looking at the stable as an option for those who really want to get access to things as soon as they drop. As Rob mentioned, even in the 613, the 614, some of these more recent stable builds, there are massive performance improvements that would directly impact not just the bottom line and the cost of running AI workloads. It will also unlock features that you previously prevented entire strategic initiatives. You can do things that were not possible. And it can take, some of these would require backporting massive components and subcomponents that may take months and months and months or even years. And in that time, the industry has moved on. If you're waiting even a week or a couple of months or 6 months to access the latest performance, latest features, you're behind the 8 ball. So getting these newest features and newest drivers and newest performance enhancements directly to customers in a way that they're confident about running it in production environments at scale, and we're talking at scale, that's one of the focuses of RLC-AI, is bring all of that latest cutting edge technology into your foundational OS. So you're getting the most out of your cutting edge hardware and using that as a stable foundation for your cutting edge software stack.
And there's one group of people who is just relentless in their push for, I want the latest and greatest thing, whether it's an innovation for speed or an innovation for model accuracy. It's AI engineers. Like, they are relentless. You read a paper and you want to go implement it, and you don't want to go start compiling your own kernels for CUDA to do it.
Right. Or have to go beat up on your infrastructure, platform ops, or DevOps team. Right. I did want to add, I think, a key thing as I started to dig in and research more to help define the feature scope for RLC-AI, it became clear to me that while right now OpenAI and ChatGPT dominate the production AI workloads, again, this is something like over 80% of what we see of AI out in the wild ultimately is API driven through ChatGPT. That is rapidly swinging. And for a couple of, 2 reasons. One is very similar to what we saw with cloud adoption. This is great. I can deploy fast and easy. I'm going to consume it. And then people stopped and said, oh, wow, wait, this is really expensive. We need to be more thoughtful, right? So that's causing people to kind of come back into their own data centers, into their own virtual private clouds, and hosting their own models. 2 is as AI becomes less of an experiment and it empowers businesses, more critical IP and specialized use cases around critical IP are being deployed. So people need sovereign AI on premise. And then 3rd, we all heard about DeepSeek. We've seen the rate at which Meta open sourcing Llama drove adoption. And now we have models, open source models like Mistral, etc., that are rapidly evolving and now able to compete with some of the services you would have gotten from OpenAI or Anthropic. So what this means is people have been able to ignore figuring out, how do I run this on-prem? How do I manage my own AI workloads? But they now have to rapidly figure it out.
Yeah. And it's important to recognize, like, in AI, the open source isn't that far behind the closed source state of the art. Like, we all remember ChatGPT's launch and what an amazing product that was the first time you used it. And like, you can run a model that was better than the original ChatGPT on your phone right now. And so just imagine going back in time and saying to yourself at the launch of ChatGPT, hey, the next phone you buy, you'll be running ChatGPT on the phone's GPU. And that took some software innovation in the models, but it also took a lot of hardware innovation in the phones.
I mean, that's the whole reason Apple moved to 16 gigs, right? Is because they wanted to be able to get Apple Intelligence rolling. So, I mean, you're seeing it across all the hardware.
Yeah. But like, there's open source small models, like I forget the app, but you literally can just download the weights. It's a few hundred megabytes and run them on your phone. It's absolutely brilliant.
Oh, yeah.
So Zach, can you define inference for me in this context and why it's important? You guys have said that word a lot, and I really should just on the side ChatGPT it, but
yeah. Well, actually, that was the example I was going to use. So when you use ChatGPT, you're doing inference. So there's a model running in OpenAI's data centers. You type some text into a box that gets packaged up into an API call that goes out to some server, and then that server does a bunch of matrix algebra to decide what words to send back to you. So that's called inference. And inference is important because that's what powers every single AI application that's interesting to humans, like, my doctor or your mom or me, or all of the AI use cases. Even, I'm an AI researcher and AI consultant, and 95% of what I do is inference. That's just models get trained once and then deployed for potentially years after the fact. And when you amortize that, you end up using a lot more compute on inference, because inference is what is useful. Inference is the entire point of training a model. If you train a model and you're never going to infer from it, maybe that was an interesting exercise. Maybe you got some papers out of that or something, but inference is fundamentally what makes models valuable. And if your belief is that AI is going to power more and more of the economy, that's a belief that there's going to be more and more inference.
I appreciate that. Thank you. It's coming together and making sense of why that's important for RLC-AI as well. Cool. So what else do we want to talk about, guys? I feel like we kind of covered a lot, but there's probably more.
I have some.
You've unleashed him.
I did want to expand on my other statement and just say, and I'd also like to get Zach's thoughts on this. But look, we are making the bet. I talked about this move from API implementation of AI and AI inferencing to on-prem. I do want to call out that, and again, similar to cloud workloads, right? I think where we're going to see a steady state is not all on-prem, self-hosted, open source. It is not all through a third party, but rather at scale, we are going to deploy our AI workloads in a hybrid manner. And as I look at it from a product standpoint, to me, what that means is we have to offer equal priority to being able to deploy on bare metal and on-prem environments, support containers to be orchestrated by Kubernetes, as well as delivering cloud images to efficiently support cloud workloads. And again, I think we are seeing the industry move towards this hybrid model. I'd ask the rest of the team if they agree with that. I'll take that as a no.
Yeah, I know, I'm sure Zach has some comments, but absolutely, we've seen that there are certain use cases that just don't make sense to build out an entire infrastructure. And if you want to test quickly, the fastest way is to go through the cloud. The cloud has the hardware, they have the stability, they have the processes. If you are trying to spin up an operation, a production inference model in a very short period of time, you don't want to wait for a new data center to be built or provisioned. You can get that up in the cloud right away, and you will always be, using the cloud at some level. Now, once you've really got an established process, maybe for cost savings, you're looking at long-term to move things on-prem. But when nothing beats the cloud for speed to deployment.
Yeah, I mean, right now, Microsoft and Meta are two of the biggest companies buying up the most chips right now. And where is all that going to go? The cloud.
Yeah.
I mean, you can't, especially if you can't get your hands on some of the newest technology. Some of it is not only very expensive, but there also have been supply issues. If you really want to run on the truest cutting edge, the latest Blackwells, it makes a lot more sense to just go and utilize what the cloud has available. Or it may be that is your only option if you're not in a position to make a very large purchase.
Yeah.
This all sounds very exciting. So is RLC-AI ready? Is this, how can people get it?
I'll take that. So RLC-AI is in active development, but we are already accepting signups for our tech preview access. So in early June, we're accepting signups now. We're engaging with people. I encourage our listeners to jump in. We want to hear from you and understand your needs. And then in early January, we will open up the bits, delivering you an image with a major set of the features that we plan to deliver for GA. And then later this quarter, we expect to be in a position to deliver a GA release. We want to start talking to you now. We want to start getting feedback from you now. we want to start building something that is built to address your needs.
Yes. Yes, that's very exciting. Yeah, the tech previews have been going really well. It's nice to have people come in and then you kind of get to be, on the ground floor being like, okay, like this is cool, great idea, but like this is how it's working in actual, reality. So like add this, do that. And it's awesome to be responsive to our customers and people who are out there doing the good work.
It's a win-win.
Yeah.
And I'll add, look, no knock on sales. I know sometimes engineers and actually the implementers of this want to be able to get their hands on technology without having to engage with the procurement process. So the nice thing about engaging in our tech preview program is, you can get the bits, you can deploy them, you can play with them. We're available. Our engineering team is available. We can have dialogue and conversations, and you can kind of safely figure out, run it through its paces and figure out if this meets your needs.
Yeah. That's exciting. Okay, so is there any key differentiators? Wow, that's a good word for me right now. That potential users should be aware of from RLC-AI and others.
Yeah, right now it is latest. You're going to be getting the latest is one of the differentiators. This is an upstream kernel, and generally we're keeping it very close to the upstream, but it's still supporting in a Rocky Linux from CIQ 9 user space. So it's the same user space you're used to. That part hasn't changed. So making sure that your software stack is still compatible in user space is a major part of this, and then you don't have to go through Linux from scratch to be able to get the most cutting edge features. Beyond that, we've also, besides the modifications and kernel level optimizations that we're adding around build time and various other compiler flags, we're also adding in additional frameworks, libraries that are used by basically everyone. PyTorch, as an example, TensorFlow. On their roadmap is the Onyx format. And then there's Hugging Face libraries, the MLOps components that having them baked in that gold image just drastically speeds up your time to token, because you don't have to sit there waiting for things to install, and then you don't have to deal with any complexity around compatibility or dependencies. So all of these things being baked in means you don't have to set that up from scratch. It's more reproducible, but it also means that you're not going to be getting certain features that are focused on other types of workloads. For example, FIPS 140-3 might not be directly applicable to AI because it's moving so quickly that you're not going to want to wait for the code to freeze long enough to be certified.
That's great. Thank you. So I'm really excited. I know that we've already had a lot of interest. People are asking us about this. They're like, yeah, because I want that new driver. I want that new hardware. Like I want to run fast. Like, let's go. So there's been a lot of interest. It's very exciting. We'll put the link to join the tech preview. And then of course you can always go to our website and fill out any form, and that comes directly to us. And we'll make sure that you get, all the bits and the pieces. And you can see Brian, he's very excited to get this in your hands. So definitely.
I want to talk to people. I want the data. I want people to get their hands on it. You called me out. You were right.
So, you want real people using it, because then you know how to make it work for real people.
Yes. That was perfect. I feel like most of you got a little final thoughts. Rob, you got a final thought here for the people?
The core difference between like what I'd say this image is and a lot of what the other images that CIQ produces is we are trying to get closer and faster to what's coming out and being very responsive to the AI market versus some of the other markets we look at without compromising on those things like hardening and security.
Yeah. Let us do the grunt work for you.
Yep.
Let's make it easy for you.
Yeah.
Awesome. Well, thank you guys. That was amazing. It was so good to get together with all of you. And I have a sneaking feeling that I'll probably be seeing all of you here sometime soon again to continue talking about the cool things that we are doing, building on top of Rocky Linux. So first of all, thank you to the Rocky Linux community for all the good work that you guys are doing and making this possible, and everyone else, and to all of the upstreams and all of the projects that we are a part of. It is very exciting. People are working on the kernel so that we can grab it and take it, and the hardware and all of the good stuff. So appreciate it. Again, go to ciq.com. We'd love to connect with you and get you set up with RLC-AI. Well, thank you guys. Have a wonderful day, and we'll talk soon.
Thanks, Rose. Appreciate you.
Thank you for being such an awesome host, Rose. Thank you, everybody.